Because there are advantages to each form of a quadratic function, it's handy to know how to go back and forth from one to the other. We're going to start with the easy direction. That's taking vertex form to standard form. It turns out to go from vertex form here to standard form, you really just have to multiply out the squared term and then collect like terms. So we'll look at two examples. So here I'm going to rewrite f of x by multiplying out the square. Now to multiply out the square, two things to keep in mind. There's the square and then there's the 2 that multiplies it. In order of operations, you always square first. So we would square this binomial. Keep the minus 4 out. That's going to come last. Now to square this binomial, remember you want to kind of FOIL it out. X times x is x squared. Then you would have the x times 3 or 3x. And then you again have x times 3 because really this is x plus 3 times x plus 3. So you need the outside and inside terms there when you FOIL it out. There is a shortcut there to just double the 3x to get 6x. And then finally multiply the 3 times itself for the last terms to get 9. So you first want to multiply out that binomial. And if you use the shortcut, you'll immediately get to the 6x right away. Then distribute the 2 as your next step in order of operations. So we get 2x squared plus 12x plus 18. Keep the minus 4 there. And then the last step is collect those two like terms. So f of x is equal to 2x squared plus 12x plus 14. If you want to, you can graph the original and then that was in vertex form and the standard form and see that you do indeed get the same graph. These two are just two alternate ways of writing the same quadratic function out. Here's one more example. Again, remember to square, and the negative is on the outside of the square, so we square the binomial first. Remember, you're going to FOIL it out technically, so x squared minus 5x plus 25. So that's squaring all of those those 2 terms times 2 terms out, so you get 4 terms. And then distribute, we'll collect the like terms inside for a minus 10x. Distribute the negative, minus x squared plus 10x minus 25 plus 8, and then collect like terms. The like terms that are left are the constant terms at the end. So that would be minus 17. So g of x is equal to negative x squared plus 10x minus 17. Again, this equation and this equation represent the same function. It's just an alternative format for it.